ሶ ሁለተኛው ጥያቄ እነዚህን ይመስላል ወደ 15 ሁለተኛው ጥያቄ 18 የሊሚት ጥያቄዎች አሉ ከቻልኩኝ ሁሉንም ለማሳየት ሞክራለሁኝ ሶ ወደ a part እንሄዳለን in the a part the limit of h square plus h square times 1 plus 1 over h square የዚህ ሊሚት ምን ይሆናል የሚለው ነው so we can rewrite this thing as this is the same as the limit of distribute እናደርግ ይሄን h square this is the same as h square plus h square over h square becomes 1 as h approaches to 0 okay this is 0 square plus 1 which is 1 okay the first part is very simple you can immediately obtain the answer for the first part መጀመሪያው part ቶሎ መናገኛት ነው የሚሆነው so let's see the second the b part in b we do have a certain limit አሁን directly substitute ብናደርግ 1 okay in this expression if you substitute 1 it becomes 0 over 0 which is called indeterminate form በዚህ ጊዜ either simplification or L'Hopital rule እንጠቀማለን so የተለያየ ሜተዶች አሳያችኋለሁ አሁን simplification ላሳያችሁ then after L'Hopital rule ተጠቅመን ሊሚት እንደ ካልኩሌት እንደምናደርግ እናያለን so this is the same as the limit of y cube minus 1 means y minus 1 times y square plus y plus 1 you can check over radical y minus 1 as y approaches to 1 ይሄንን አንድ ነገር እዚህ ጋር ማወቅ ያለብን a cube minus b cube ማለት ይሄ ማለት a minus b times a square plus ab plus b square ይሄንን factorization ካወቀን we can understand the factorization form of the numerator so again አሁንም እቺ y minus 1 ን ምን አድርገን መጻፍ እንችላለን y minus 1 can also be written as radical y minus 1 times radical y plus 1 okay ለብቻ y minus 1 እንደዚህ ሊጻፍ ይችላል then y square plus y plus 1 over radical y minus 1 ይሆናል as y approaches to 1 so now we have something that can be cancelled out ስለዚህ ምን ይሆናል ማለት ነው this is the same as the limit of radical y plus 1 times y square plus y plus 1 now you can directly substitute y is equals to 1 y is equals to 1 and substitute እናደርግ radical 1 plus 1 plus 1 square plus 1 plus 1 by ቦታ substitute 1 radical 1 is 1 plus 1 is 2 so this becomes 2 times 1 plus 1 plus 1 which is 3 so the result is 6 okay L'Hopital rule የሚባል ቴክኒክም መጠቀም ትችላላችሁ but here I want to show you how you can evaluate this limit using factorization limit ላይ smart መሆን ከፈለጋችሁ you need to be very smart in simplification of different things okay different expression እንዴት simplify እንደሚደረግ ማወቅ አለብን ማለት ነው okay now I will take you to the C part we have seen the A part and the B part in A the answer is 1 in B the answer is 6 okay now let's see the C part when we come to the C part you can use simplification you can also use L'Hopital rule okay እኔ እዚህ ሲ ጥያቄ ውስጥ simplification እጠቀማለሁ ካላችሁ ስቴፑ ሚረዝም ይመስለኛል so I prefer to use L'Hopital rule to calculate the limit of question I mean the C part okay የሲም part limit ለመስራት L'Hopital rule እንጠቀማለን why do we use L'Hopital rule the question says the limit of the square root of 7 plus cubed root of x minus 3 over x minus 8 as x approaches to 8 okay why do we use L'Hopital rule directly substitute ብናደርግ 8ን radical 7 plus cubed root of 8 minus 3 cubed root of 8 is 2. Okay, this means radical 7 plus 2 minus 3, the result is 3 minus 3, which is 0. Okay, the numerator becomes 0. If you substitute here, it becomes 0. If you substitute here in place of x, if you substitute 8, it becomes 0. 0 over 0 mihon kohona, we can apply L'Hopital rule. Okay, so let us apply L'Hopital rule. Mendeno L'Hopital rule malet, if we have such case 0 over 0 or indeterminate form, you can calculate by converting this into the derivative of the numerator 7 plus cubed root of x minus 3 ለብቻ derivative እናደርጋለን over the derivative of x minus 8 as x approaches to 8. Now the derivative of x minus 8 is the derivative of x minus 8 is 1. Okay, automatically x derivative minus 8 derivative. So the derivative of this part, the denominator is 1. So this means the limit of the derivative of 7 plus cubed root of x minus the derivative of 3, which is 0, over 1 as x approaches to 8. Now, what is the derivative of 7 plus cubed root of x? This means 1 over 2 times radical 7 plus cubed root of x times cubed root of x derivative. This means 1 over 6 into x to the power of minus 2 over 3 over a square root of 7 plus cubed root of x. Okay, in place of here, እዚች ጋር በዚህ ቦታ ይሄን substitute እናደርጋለን. In place of this, we can substitute this one. So this means the limit of 1 over 6 times x to the power of minus 2 over 3 over square root of 7 plus cubed root of x as x approaches to 8. Now you can directly substitute 8. 8 and substitute another gallon. So it means 1 over 6 times 8 the power of minus 2 over 3. Okay, over square root of 7 plus cubed root of 8. Cubed root of 8 is 2. Okay, this cubed root of 8 is 2. 2 plus 7 is 9. Square root of 9 is 3. Therefore, 1 over 6 times 8 the power of minus 2 over 3 over 3, which is 1 over 18 times 8 the power of minus 2 over 3. By the way, 8 the power of minus 2 over 3 means 2 the power of minus 2, which is 1 over 4. So this becomes 1 over 18 times 1 over 4. The result is 1 over 72. Okay, therefore the limit of the expression in C becomes 1 over 72. Now let's see the solution for D part. የዲን part እናያለን. So in D we have the limit of y the power of 1 over 3 minus 2 over y minus 8 as y approaches to 8. If you directly substitute 8 and substitute ብናደርግ y the power of 8 the power of 1 over 3 is 2. So 2 minus 2 is 0. 0 over 0 ይሆናል. If you directly substitute 8, it becomes 0 over 0, which is called indeterminate form. Okay, so if we have indeterminate form, we can apply L'Hopital rule, which is the same as the derivative of the numerator, the limit of the derivative of the numerator over the derivative of the denominator as y approaches to 8. Okay, indeterminate form ምን ማለት እንደሆነ ለማስታወስ ያህል 0 over 0, 0 over infinity, infinity over 0, infinity over infinity, all these are indeterminate form. So this can be written as the limit of 1 over 3 the power of y the power of minus 2 over 3 over 1. The derivative of y minus 8 is 1. We are taking the derivative with respect to y. So this is as y approaches to 8. So now we can directly substitute 8. 1 over 3 times 8 the power of minus 2 over 3. Okay, this is the same as 1 over 3 into 8 the power of 1 over 3 the whole minus 2. Okay, 8 the power of 1 over 3 is 2. So ምን ይሆናል ማለት ነው? This is 1 over 3 into 2 times 2 the power of minus 2, 1 over 4. Okay, 1 over 4. So the result will be 1 over 12. Okay, by the way, you can also evaluate this limit by factorization. Okay, so the limit of this expression is 1 over 12. Okay, ወደ e part ወስዳችኋለሁ። ወደ e part ስንሄድ we have this the limit of, in e we do have the limit of x square minus 4 over x the power of 3 minus 8 as x approaches to minus 2. If you directly substitute minus 2, the result will be minus 2 square minus 4 over minus 2 cube minus 8. Okay, this is 4 minus 4 over minus 2 the power of 3 is minus 8. Okay, this is 0 over minus 16. The result is 0. I think if the question is as x approaches to 2, it requires some technical game. As x approaches to 2 ቢሆን ኖሮ ጥያቄውን ትንሽ ጠንከር ማድረግ ይቻላል. But this is a straightforward. The limit of this part is 0. Okay, already we have obtained the limit of this part, the a part. Okay, the limit of the a part is 1 over 12. Okay, the limit of the d part is 1 over 12, e part 0. So the limit in f part, in f we do have the limit of x square over sec x minus 1 as x approaches to 0. Okay, always check first by substituting the number. If you check x is equals to 0, it becomes 0 over 0. Okay, sec 0 is 1, 1 minus 1 is 0. So the result will be 0 over 0. In this case, we can immediately use a L'Hopital rule, which is the same as the limit of x square derivative over sec x derivative, sec x minus 1 derivative as x approaches to 0. Okay, in this case, the limit becomes the limit of 2x over the sec x derivative minus 1 derivative. 1 derivative is 0. Okay, derivative of 1 is a constant number, is 0, and the derivative of sec x is, you can apply quotient rule. So this is the same as 1 over cos derivative. The result is tan x sec x. Okay, derivative of sec x means tan x sec x. So in place of this part, you can substitute this one. So ምን ይሆናል ማለት ነው? This limit becomes the limit of 2x over tan x sec x. Okay, now let's substitute x is equals to 0. X is equals to 0 and substitute again, check እናደርጋለን. Still it becomes 0 over 0. Again, ምን እንጠቀማለን? አሁንም 0 over 0 ካለ you can apply L'Hopital rule again and again. So the limit of 2x derivative over tan x sec x derivative. Okay, you can take the derivative for numerators and the numerator and denominator separately. ይሄ ምን ይሆናል ማለት ነው? 2x derivative is 2. Okay, 2x derivative is 2 over, use product rule for this. If you use the product rule, it becomes tan x derivative times sec x plus tan x times sec x derivative. Okay, ምን ይሆናል ማለት ነው? As x approaches to 0, this becomes the limit of 2 over tan x derivative means sec square x. Okay, sec square x times sec x plus sec derivative is this one here, tan x sec x. So tan x times tan x sec x. Okay, so this means the limit of 2 over sec cube x plus tan square x sec x. Okay, now substitute as x approaches to 0. ይሄ ምን ይሆናል ማለት ነው? 2 over sec 0 is 1 square plus tan 0 is 0 times sec x, sec 0 is 1. So this means 2 over 1 plus 0, the result is 2 over 1, which is 2. Therefore, the limit of the C part is 2. Okay, this is the limit. What the G እንሄዳለን? G ውስጥ we are asked the limit of 2x square plus x over sin x as x approaches to 0. You can use L'Hopital rule, but for now, let me use factorization. So it depends on your interest. Okay, ስትፈልጉ L'Hopital rule ሚቻል ከሆነ በፋክቶራይዜሽን ቶሎ የሚመጣ ከሆነ መልሱ you can use also factorization. So I'm just using like this, እንደዚህ factorize ማድረግ ይቻላል. So this is the same as the limit of x over sin x as x approaches to 0 times 2x plus 1. Okay, now you can apply the rules for limit separately. የዚህን ሊሚት ለብቻ እንሰራለን. So it becomes the limit of x over sin x as x approaches to 0 times the limit of 2x plus 1 as x approaches to 0. Factorization የተጠቀምኩት እንደዚህ ቶሎ ስለሚመጣ ነው. We all know that the limit of x over sin x is 1. ይሄንን ሩል በውስጣችሁ ያዙ. You can also verify using this L'Hopital rule. L'Hopital ruleን ብትጠቀሙ እውነት መሆኑን ቼክ ማድረግ ትችላላችሁ. And so ይሄ ምን ይሆናል ማለት ነው? 1 times the limit of this part. አሁን directly substitute ማድረግ ይቻላል። 0 እዚህ ውስጥ 2 times 0 plus 1 is 1. So the limit of this part is 1. So the answer for G part is 1. Okay, next we have the H part. When we go to the H part, we have the limit of x square into 1 plus cot square 3x as x approaches to 0. So this can also be written as the limit of x square plus x square cot square 3x as x approaches to 0. So ለብቻ እየሰራን እንሄዳለን. So this means the limit of x square as x approaches to 0 plus the limit of x square cot square 3x as x approaches to 0. obviously the limit of this part, the limit of x square as x approaches to 0 ይሆናል። so የዚህን የx square cot square 3xን ሊሚት ካልኩሌት እናደርጋለን። so this is equivalent to the limit of x square times cot is the reciprocal of tan, so cot square means cos square 3x over sine square 3x as x approaches to 0. So this can be written as the limit of x square over sine 3x as x approaches to 0 times the limit of cos square 3x as x approaches to 0. እንደዚህ ስፕሊት ማድረግ እንችላለን። ኦኬ ይሄንን ቀጥታ ምን ማድረግ ይቻላል? x square over sine square 3x times cos square 3x ማድረግ ስለሚቻል now the limit of cos square 3x as x approaches to 0, this part is 1. Okay, this part is 1. We need to calculate the limit of x square over sine square 3x. Here it is square, there is a square here. So ይሄ ምን ይሆናል ማለት ነው? The limit of x times x square means x times x, sine square means sine 3x times sine 3x. Okay, as x approaches to 0. So we can rewrite this thing as the 1 over 9 times the limit of 3x over sine 3x times the limit of 3x over sine 3x as x approaches to 0 in both cases. Okay, ለምንድን ነው እዚህ ጋር እንደዚህ የጻፍኩት? እዚህ ጋርም 3 አለን፣ እዚህ ጋርም 3 አለን። 3 times 3 is 9. So over 9 ያለው ከዚች ኮኤፊሽንት 1 ጋር ተመሳሳይ ነው የሚሆነው። Now we can see that the limit of 3x over sine 3x is 1. The limit of 3x over sine 3x is 1. So this means 1 over 9 times 1 times 1, which is 1 over 9. Okay, therefore the limit of the expression in h is 1 over 9. Okay, now we are going to evaluate the limit for this expression in I. The limit is the limit of sine cube x plus sine x times cos square x over x minus pi as x approaches to pi. Now if you directly substitute x is equals to pi directly everywhere substitute ብታደርጉ you get 0 over 0, which is indeterminate. So either we use a L'Hopital rule or other simplification technique. For now I want to say let x minus pi is some number y. If x minus pi is y, as x approaches to pi, y will approaches to 0. Okay, if you replace x minus pi by y, whenever x is approaching pi, y will be 0. So y will be approaching to 0. So here from this, in place of x, you can substitute x is equals to y plus pi. Okay, you can shift this. So in place of x, substitute y plus pi. So the given limit becomes the limit of sine cube x means y plus pi times plus sine of y plus pi times cos square y plus pi over y as y approaches to 0. Already the variable x is changed. So the other thing, you need to know some trigonometric identities. So using trigonometric identities, sine of y plus pi means the negative of sine y. Okay, you can check by using trigonometric identities. So in place of sine of y plus pi, you can get this. So let us rewrite this thing. ይሄ ምን ይሆናል ማለት ነው? Okay, this means the limit of in place of sine of y plus pi, I can substitute minus sine y. Okay, there is cube here, minus, because this is minus sine y, minus sine y times cos square y plus pi over y. I don't want to change this by using trigonometric identities. It is not required for now. So I can rewrite this thing like this, minus the limit of sine cube y over y. This y is common for this part and this part. So as y approaches to 0, then minus the limit of sine y over y times cos square y plus pi as y approaches to 0. Okay, now I can rewrite this thing like this. This can be written as minus the limit of sine y over y as y approaches to 0. Sine cube can be written as sine y times sine square y. So the limit of sine square y as y approaches to 0 minus the limit of sine y over y as y approaches to 0 times the limit of cos square y plus pi as y approaches to 0. Now this part is 1. The limit of sine y over y as y approaches to 0 is 1. So this means minus this limit is 1 times the limit of sine square y as y approaches to 0 is 0 minus this part is 1, and the limit of cos square y plus pi is 1. Okay, you can directly substitute 0. Cos pi becomes minus 1. Minus 1 square is 1. So this means this part becomes 0. Minus 1 times 1 is minus 1. Okay, therefore the limit of the expression in I is minus 1. We are asked the limit of the limit of 2 plus sine square x over x square as x approaches to infinity. So this can be written as the limit of 2 over x square plus sine square x over x square as x approaches to infinity. Okay, so we can calculate here the limit separately. So this is the same as the limit of 2 over x square as x approaches to infinity plus the limit of sine square x over x square as x approaches to infinity. Now here there is something that we can observe. The limit of 2 over x square as x approaches to infinity, this is obviously 0. Okay, here part limit 2 over very big number is 0. So we need to know the limit of this part. Okay, 0 plus something will be our limit. So to calculate the limit of this part, we need to apply some rules. So we know that sine and cosine are between minus 1 and 1. Okay, so the same thing will happen if we square it. If we square it, still the squared value of sine is between minus 1 and 1. In fact, it is between 0 and 1, but we can also write like this. So we can apply here squeezing theorem, or let us take division both sides by x squared, by x squared, by x squared. Now you can take squeezing theorem. By squeezing theorem, we can evaluate the limit of this part. Okay, so the limit of minus 1 over x squared as x approaches to infinity is less than or equals to the limit of sine square x over x squared as x approaches to infinity. This is less than or equals to the limit of 1 over x squared as x approaches to infinity. Okay, so obviously this part, it is 0. 0 is less than or equals to the limit of sine square x over x squared as x approaches to infinity. This is also less than or equals to the limit of this part, which is 0. Okay, since this expression is between 0 and 0, obviously the limit of sine square x over x squared as x approaches to infinity is 0. በሁለት ዜሮዎች መካከል ሌላ ነምበር አይኖርም. Obviously this limit is 0, so this part is 0 plus this part is 0, so the limit of these two parts is 0 plus 0. Therefore the given limit will be, therefore the limit of 2 plus sine square x over x squared as x approaches to infinity will be 0. Okay, the limit of this expression is 0. In K part, we have the limit of 1 minus 1 over 3x the power of 2x plus 1 as x approaches to infinity. So this kind of limit requires some kind of different techniques than we have seen so far. So here I will show you how we can solve the limit of this part. So let us rearrange this limit. So this becomes the limit of 1 plus minus 1 over 3 over x the power of 2x plus 1. Okay, here I just write this part in this form. So again, this can also be written as the limit of 1 plus minus 1 over 3 over x the power of 2x as x approaches to infinity times 1 plus minus 1 over 3 over x the power of 1. Okay, so I converted this into this part using the rules of exponential. So we can now calculate the limit separately. So this can be written as the limit of 1 plus minus 1 over 3 over x the power of x the whole square. We can rewrite like this as x approaches to infinity times the limit of 1 plus minus 1 over 3 over x as x approaches to infinity. Now here you need to observe this part. Here this term will goes to 0, so 1 plus 0 is 1. So the whole this thing becomes 1. The limit of this expression is 1. So we can have only this part, the limit of 1 plus minus 1 over 3 over x the power of x the whole square as x approaches to infinity. So to remind you some of the rules on such kind of limit, whenever we have the limit of this form, 1 plus k over x the power of x as x approaches to infinity, such limit can be expressed as e the power of k. So we can observe the internal expression. Okay, whenever we observe the internal expression, it becomes e the power of minus 1 over 3. Okay, we do have the whole 2, so this becomes e the power of minus 2 over 3. Okay, Okay, this is the limit of e the power of x minus e the power of minus x over e the power of 2x minus e the power of minus 2x as x approaches to infinity. Okay, so I'm going to write this thing as e the power of x minus e the power of minus x means 1 over e the power of x over the denominator becomes e the power of 2x minus 1 over e the power of 2x as x approaches to infinity. Now this means the limit of e the power of 2x minus 1 over e the power of x the whole e the power of 4x minus 1 over e the power of 2x as x approaches to infinity. So this can also be written as the limit of e the power of 2x minus 1 over e the power of x times e the power of 2x over e the power of 4x minus 1 as x approaches to infinity. Okay, now let us simplify this thing. So this can be written as the limit of e the power of 2x minus 1 times e the power of 2x minus x means e the power of x. Okay, here you can simplify this part by this part, so it becomes e the power of x over e the power of 4x minus 1 as x approaches to infinity. Now this 4x, e the power of 4x minus 1 means e the power of 2x minus 1 times e the power of 2x plus 1. So you can replace this part by this factorized form. So the limit becomes e the power of 2x minus 1 times e the power of x over e the power of 2x minus 1 times e the power of 2x plus 1. Now this can be simplified. Okay, so the simplified becomes the limit of e the power of x over e the power of 2x plus 1. Here you can observe what the values looks like whenever you substitute very big number in place of x. So this limit becomes infinite over infinite, which is called indeterminate form. So whenever we have indeterminate form, we can apply a L'Hopital rule so that I can write this limit as the limit of e the power of x derivative over e the power of 2x plus 1 derivative as x approaches to infinity. So this becomes the limit of e the power of x over 2 times e the power of 2x as x approaches to infinity, because the derivative of a constant becomes 0. So this is exactly the same as half of the limit of e the power of x over e the power of 2x as x approaches to infinity. So e the power of x over e the power of 2x means e the power of minus x as x approaches to infinity, or you can make it 1 over e the power of x. Okay, so this means half of the limit of 1 over e the power of x as x approaches to infinity. So this becomes, the limit of this becomes 0. So half times 0 becomes 0. Okay. Okay, in M part, we have the limit of 3x plus 4 over radical 2x square minus 5 as x approaches to infinity. እንደዚህ አይነት ጥያቄ ብዙ ጊዜ ኦብዘርቭ በማድረግ በማየት ብቻ ይመለሳል። Okay, for the time being, let me show you how you can obtain the limit. So take the divide both the numerator and the denominator by x. So it becomes 3x plus 4 over x over radical 2x squared minus 5 over x as x approaches to infinity. These two are the same. Okay, these two are the same because a over b can be written as a over c over b over c. Okay, you can divide the numerator and the denominator by the same number, so it is equivalent. So they are the same. So this means the limit of 3 plus 4 over x over you can substitute or you can insert this x into the radical sigaba square on. Okay, so it becomes 2x squared minus 5 over x squared as x approaches to infinity. So this means the limit of 3 plus 4 over x over in the radical 2 minus 5 over x squared as x approaches to infinity. So obviously this term will be approaching 0, it becomes almost 0, and this term becomes 0. So the remaining term will be 3 over radical 2. Okay, therefore the limit for m part will be 3 over radical 2, or you can write 3 radical 2 over 2 ብላችሁ መጻፍ ትችላላችሁ. So this is the answer for m part. Now let's see the solution for n part. Okay, in n we have the limit of radical t squared plus t minus radical t squared plus 4 as t approaches to infinity. Okay, now let us rewrite this in some other form. Okay, so this is equivalent to the limit of radical t squared plus t means t squared into 1 plus 1 over t. Okay, we can rewrite like this, minus in the radical t squared plus 4 means t squared into 1 plus 4 over t, okay, as t approaches to infinity. Okay, so we can write like this. So here, as t approaches to infinity, t is positive infinity, so t is considered to be positive. So we can factor out t squared from, we can take out t squared from the radical. So it is equivalent to the limit of t into radical 1 plus 1 over t minus t into radical 1 plus 4 over t squared, okay, as t approaches to infinity. Now we have t in common here, so this is equivalent to the limit of t into radical 1 plus 1 over t minus radical 1 plus 4 over t squared. Okay, so here t is approaching to positive infinity. Now let us again rewrite this thing. So t can be written as like this. So this limit can also be written as the limit of radical 1 plus 1 over t minus radical 1 plus 4 over t squared. There were t, so I can take as 1 over t as t approaches to infinity. Okay, so I took this t in here in the denominator. So now let t is 1 over x. Okay, so as t approaches to infinity, definitely x will tend to 0, because t is equals to 1 over x means x becomes 1 over t. So as t approaches to positive infinity, x will approaches to 0. So let us replace this notation. So the given limit becomes the limit of radical 1 plus x minus radical 1 plus 4x. Okay, because t square means 1 over x square. So I can make like this, x square, yes, it's x square over x as x approaches to 0, okay, because t square from here, t square becomes 1 over x square, or x square becomes 1 over t square. So now if we directly substitute 0 in this expression, the result becomes 0 over 0, which is indeterminate. Therefore, we can apply L'Hopital rule in this limit. Okay, applying L'Hopital rule, we can get this kind of limit. So this becomes the limit of 1 plus in the radical 1 plus x minus in the radical 1 plus 4x square derivative over x derivative as x approaches to 0. So this is equivalent to the limit of 1 over 2 radical 1 plus x as x approaches to 0. Okay, this part is already 1. So minus the limit of 8x over 2 times radical 1 plus 4x square as x approaches to 0. Okay, so you can apply chain rule to find the derivative of this part. So this becomes the limit of this part. Okay, this part becomes 0. The limit of this part is obviously, you can directly substitute 0, so it becomes 1 over 2 times radical 1 plus 0, which is 1 over 2. Okay, in O we have the O part, we have the limit of x cubed plus 1, the power of 1 over 3 over radical x squared minus 3 as x approaches to infinity. So this limit is the same as the limit of x cubed plus 1, the power of 1 over 3 over x. You can divide both the numerator and the denominator by the same quantity, minus x squared minus 3 over x as x approaches to infinity. So this x can be also written as the limit of x cubed plus 1, the power of 1 over 3, okay, over x. This x can also be written as x cubed, the power of 1 over 3, okay, over in the denominator we have x squared minus 3 over x means radical x squared. Okay, so x is the same as x cubed, the power of 1 over 3. I used this thing. Again, I also used x is equal to square root of x squared for positive x, because x is approaching to positive infinity. So this can also be written as the limit of x cubed plus 1 over x cubed, the power of 1 over 3. Okay, you can take the same power over radical x squared minus 3 over x squared as x approaches to infinity. So this is the same as the limit of 1 plus 1 over x cubed, the whole 1 over 3, the power of 1 over 3 over in the radical 1 minus 3 over x squared as x approaches to infinity. Now everything is visible. Okay, whenever x is getting big and big, 1 over x cubed becomes 0, 3 over x squared becomes 0. Okay, so the only thing that will be remaining is 1 the power of 1 over 3 over square root of 1. Okay, for real numbers, 1 the power of 1 over 3 is 1, over square root of 1 is 1. The result is 1. Okay, so the limit of this part is 1. In P we have the limit of 3 the power of x minus 5 the power of x over 3 the power of x plus 5 the power of x as x approaches to infinity. So here we need to be very technical. So we can rewrite this thing like 5 the power of x into 3 the power of x over 5 the power of x minus 1 over 5 the power of x into 3 the power of x over 5 the power of x plus 1 as x approaches to infinity. Okay, I just factored 5 the power of x from both numerator and the denominator. Now this can be cancelled out, therefore this becomes the limit of 3 over 5 the power of x, the limit of 3 over 5 the power of x minus 1 over 3 over 5 the power of x plus 1 as x approaches to infinity. Now here, it's obvious that the limit of 3 over 5 the power of x as x approaches to infinity is 0. Okay, the limit of this part, this term will be 0 and this term will be 0. So the result will be minus 1 over 1. So the limit of the given expression becomes minus 1. So the limit of this part is minus 1. Now let us see the limit for Q part. In Q we have the limit of the absolute value of x plus 2 minus 1 over 1 minus absolute value of x as x approaching to minus 1. Here, before we evaluate this limit, we have to specify this absolute value. Absolute value of x plus 2 becomes x plus 2 itself, for x greater than minus 2. Otherwise, it is 0 whenever x is minus 2. For x less than minus 2, the result will be minus of x plus 2. This happens whenever x is less than minus 2. Similarly, absolute value of x is positive x for x positive, 0 for x 0, otherwise minus x. By definition, absolute value of x is minus x for x less than 0, for x negative. So we have to keep in our mind this thing whenever we evaluate the given limit. So for x approaching minus 1, the given limit becomes like this. The limit of absolute value of x plus 2 becomes x plus 2 itself, for x approaching minus 1. Okay, because minus 1 is something greater than minus 2, so we can directly take x plus 2 itself over 1 minus absolute value of x will be taken as minus x for x negative number. So as x approaches to negative 1, we take absolute value of x as a negative x. So this becomes the limit of x minus 1, x plus 1 over 1 plus x as x approaches to minus 1. Now, x plus 1 by x plus 1, the result is 1. So the limit of 1 as x approaches to any number is 1 itself. Okay, so the limit of this expression is 1 for x approaches to negative 1. So the other part is the limit of the absolute value of x cubed minus x squared over x cubed plus x squared as x approaches to 0. Here we will apply the concept of absolute value. So absolute value of x cubed becomes x cubed itself for x positive, and 0 whenever x is 0. Otherwise minus x cubed, we will replace minus x cubed for x negative. Okay, so this absolute value of x cubed depends on the value or the sign of x. So this limit exists if the right hand side and the left hand side limits are the same, because if the limit exists, the value should be unique. So let's evaluate the limit from the left and from the right. So for x approaching 0 from the left, for x approaching 0 from the left, we take absolute value of x cubed to be negative x cubed. So it becomes minus x cubed minus x squared over x cubed plus x squared as x approaching 0 from the left. That means whenever we consider negative values for x, we take absolute value of x cubed by negative x cubed. So this means the limit of minus into x cubed plus x squared over x cubed plus x squared as x approaching 0 from the left. Now this can be cancelled out. The result becomes, the ratio of these two becomes negative 1. So the limit of negative 1 as x approaching to any number is negative 1 itself. So the left hand side limit for this limit is negative 1. So the right hand side limit should be the same as the left hand side limit, so that the limit exists. So now let us consider the right hand side limit. The limit of absolute value of x cubed becomes x cubed minus x squared over x cubed plus x squared for x approaching 0 from the right. That means whenever we consider positive values for for absolute values, we consider absolute value of x cubed by x cubed. So this is, if you see the limit of this expression, this becomes 0 over 0. Therefore, we apply L'Hopital rule. So take x cubed minus x squared derivative over x cubed plus x squared derivative as x approaching 0 from the right. So this means the limit of 3x squared minus 2x over 3x squared plus 2x as x approaching 0 from the right. Still, when we substitute 0, it becomes 0 over 0, which is indeterminate form. So again, we apply a L'Hopital rule, okay, over 3x squared plus 2x derivative as x approaches to 0 from the right. Then this limit becomes the limit of 6x minus 2 over 6x plus 2 as x approaching 0 from the right. Now you can directly substitute 0. Therefore, it becomes 0 minus 2 over 0 plus 2, which is minus 2 over 2. The result is minus 1. You see, the right hand side limit and the left hand side limit of this expression are the same. In both cases, it is minus 1. So the limit exists and this limit is minus 1. Okay.